For centuries, humanity believed the solar system was isolated, a closed neighborhood of planets, moons, comets, and drifting rocks orbiting a single star. But in October 2017, that belief changed forever. Something entered our solar system from the darkness between the stars. It was not born here. It did not belong to the sun. And it was moving so fast that nothing in our system could hold it. Astronomers first noticed a faint object racing across the sky at extraordinary speed. At the beginning, scientists assumed it was another comet or asteroid, perhaps thrown inward from the distant outer regions beyond Neptune. That seemed reasonable. Objects from the edge of the solar system occasionally travel inward after gravitational disturbances. But within days, observations revealed something far stranger. The object followed a hyperbolic path, an open trajectory that guaranteed it would never orbit the sun again. It was not trapped by solar gravity like planets or ordinary comets. It had arrived from interstellar space and was already on its way out. Humanity was witnessing the first confirmed visitor from another star system. The object received the name Oumuamua, a Hawaiian word often translated as a messenger arriving from afar. The name fit perfectly because this traveler had crossed unimaginable distances before briefly passing through our cosmic neighborhood. As telescopes around the world focused on it, scientists expected familiar behavior. Normally, when comets approach the sun, heat causes frozen material to evaporate. Gas and dust escape into space, creating a glowing cloud called a coma and often a bright tail pushed away by solar wind. Oumuamua showed none of these signs. No visible gas. No dust cloud. No tail. It appeared strangely clean and inactive. Then researchers discovered another mystery. Its motion was changing slightly as it traveled away from the sun. The acceleration was tiny but measurable. Gravity alone could not fully explain it. Something was gently pushing the object. If it had behaved like a normal comet, escaping gas could easily account for the extra motion. But observations showed no evidence of outgassing. This forced scientists to consider other explanations. Some proposed that hidden volatile materials such as hydrogen ice or nitrogen ice could evaporate invisibly under sunlight. Others argued that these materials would likely not survive the harsh conditions of interstellar space for millions of years. Another possibility attracted worldwide attention. What if the object was extremely thin and lightweight? Sunlight itself exerts pressure because photons carry momentum. Although the force is incredibly weak, it can slowly accelerate objects with large surface areas and very low mass. This principle is already used in experimental spacecraft designs known as solar sails. If Oumuamua had an unusually flat or thin structure, radiation pressure from sunlight could explain its strange acceleration. That idea led to intense debate because it raised a dramatic possibility. Could the object have been artificial? Not necessarily an active spacecraft or alien probe, but perhaps some form of engineered debris drifting through the galaxy. Most scientists urged caution. The available data was limited, and extraordinary conclusions require strong evidence. By the time detailed analysis began, Oumuamua was already leaving the solar system at enormous speed. Humanity had only a short observational window before it vanished into deep space. Even so, the information gathered revealed unusual characteristics. Its brightness fluctuated dramatically as it rotated, suggesting a highly elongated or flattened shape unlike most known asteroids. Some researchers described it as cigar-shaped, while others favored a pancake-like form. Either interpretation made it one of the strangest objects ever observed. Its surface also appeared dark and reddish, likely altered by cosmic radiation during its long journey through interstellar space. Over immense periods of time, Energetic particles can chemically transform surfaces, producing complex carbon-rich compounds. Scientists detected hints of organic chemistry, not evidence of life itself, but ingredients commonly associated with the chemistry that can support life under suitable conditions. Researchers believe Oumuamua probably formed in another planetary system billions of years ago. At some point, gravitational chaos may have ejected it into the galaxy. A migrating giant planet, a close stellar encounter, or violent early system formation could have launched it into interstellar space. From then on, it wandered alone through the Milky Way, crossing enormous distances in complete darkness. For untold ages, it drifted between stars. It may have passed countless worlds and stellar systems long before reaching ours. Then, by pure coincidence, its path intersected with humanity at the exact moment our civilization had developed telescopes powerful enough to detect it. Oumuamua also changed how scientists think about interstellar objects. In 2019, another visitor named Borisov entered the solar system. Unlike Oumuamua, Borisov behaved exactly like a normal comet, producing a visible coma and tail. This confirmed that objects from other star systems are likely far more common than once believed. Many experts now think interstellar debris constantly moves through our solar system unnoticed. Most objects are probably too small, too dark, or too distant to detect. Each one may carry chemical fingerprints from distant planetary systems, revealing clues about how planets form and evolve across the galaxy. Some scientists connect these discoveries to the idea of panspermia, the hypothesis that the building blocks of life, or even microscopic organisms, could travel between star systems aboard rocks, comets, or icy bodies. If true, life's ingredients may spread naturally across the galaxy over billions of years. Oumuamua therefore became more than an astronomical curiosity. It became evidence that the galaxy is dynamic, connected, and constantly exchanging material between stars. The encounter also exposed a weakness in humanity's capabilities. We noticed the object only after it had already passed closest to the Sun. There was no spacecraft ready to intercept it. No rapid mission existed to study it up close. It arrived unexpectedly and disappeared before we could truly understand it. That realization has motivated new efforts to prepare for future visitors. Advanced sky surveys are being designed to detect interstellar objects much earlier. Scientists are studying rapid response spacecraft concepts capable of launching quickly toward newly discovered targets. Future missions may one day intercept an interstellar traveler directly, capturing detailed images and measurements instead of relying solely on distant telescopes. Until then, Oumuamua remains one of the greatest mysteries ever to pass through our solar system. A fragment from another star system. A survivor of cosmic time. A silent traveler that wandered across the galaxy for perhaps billions of years before briefly appearing in humanity's skies and vanishing once again into the darkness between the stars. And somewhere beyond the outer edge of our solar system, countless other interstellar wanderers may already be moving silently through space, unseen and ancient, waiting for the moment when another one crosses our path again. Long before humanity built telescopes or spacecraft, the galaxy was already alive with motion. Stars were born, planets formed, worlds collided, and fragments of those violent events were thrown endlessly into space. Entire planetary systems scattered debris into the darkness between stars. Most of it drifted unnoticed for billions of years. But sometimes, one of those travelers crosses paths with another solar system. And in rare moments, civilizations are advanced enough to see it happen. After Oumuamua disappeared into deep space, scientists began asking a disturbing question. What if objects like this have entered our solar system many times before? Not once. Not twice. but thousands, perhaps millions of times throughout Earth's history. The truth is, our solar system is not sealed off from the rest of the galaxy. It moves constantly through the Milky Way, orbiting the galactic center at incredible speed. As it travels, it passes through clouds of gas, dust, radiation, and wandering interstellar debris. Invisible objects may cross through our planetary neighborhood every single year without detection. Most are probably tiny, no larger than rocks or grains of dust. But some could be massive, ancient bodies traveling silently between the stars for longer than human civilization has existed. Modern simulations suggest there may be trillions of interstellar objects drifting through the Milky Way at this very moment. Some are likely remnants of shattered planets. Others may be fragments ejected during the chaotic formation of young star systems. Every solar system in the galaxy acts like a giant gravitational slingshot, occasionally throwing material outward into interstellar space. That means Earth itself may contain matter that originated around other stars. Tiny interstellar particles regularly fall through Earth's atmosphere. Most burn up unnoticed. Some survive as microscopic grains embedded in ocean sediments or ancient ice. Scientists have already identified unusual isotopes in certain meteorites that appear older than our solar system itself. These grains may have formed around distant stars before the Sun was even born. In a sense, pieces of alien worlds may already exist on Earth.